let us see reasons for this particular method. So when we are using this laboratory method, we are using this equation in which we are maintaining temperature less than 200 degree centigrade, and as a product we are getting sodium bisulfate. When we are keeping temperature more than 200 degree centigrade, we are getting product sodium sulfate. When hydrogen is there in between, it named as bisulfate. Wherever the hydrogen is not there, the formula is Na2SO4 and it is sodium sulfate. Sodium bisulfate, sodium sulfate. Now let us see the particular reasons for each. First one, reactants. Why we are using these two reactants? First, NaCl. Why we are using NaCl? Because it is cheap and easily available. We know that sodium chloride we are also using as a common salt in our kitchen. So it is very easy to get, it is cheap and it is available. Second, concentrated H2SO4. Why we are using it? Because it is non-volatile in nature. What is the meaning of volatile? For example, nail polish remover. When you are using a nail polish remover, it is volatile. Automatically it will evaporate in atmosphere. So that is volatile nature. But H2SO4 is non-volatile and it has high boiling point. Why we want to use that? Because we are maintaining temperature almost 190 and not beyond 200 but almost 190. So we need that whatever reactant we are getting here, its boiling point should be high. Then concentrated nitric acid, HNO3 is nitric acid, that we are not using. So why we are using H2SO4 and we are not using concentrated HNO3? Because its nature is volatile. It generates fumes. So whenever it is reacting with NaCl, its fumes may interfere in our product and byproduct. So that's why we are not using HNO3. We are using only H2SO4. And what is the reason behind that? It is non-volatile and it has high boiling point. So this is all about reactant, that why we are using NaCl and concentrated H2SO4. But we are not using concentrated HNO3. Second reason, why we are maintaining a temperature less than 200. And if we will keep a temperature more than 200 degrees centigrade, then what will happen? So when we are answering this, that why we are keeping temperature at less than 200 degrees centigrade, then we have to show the observation that if we will keep a temperature beyond 200, what will happen? And all these things will happen, and that's why we are not keeping temperature beyond 200 degrees centigrade. First, fuel will be wasted. Obviously, if we can carrying out a temperature less than 200 degrees centigrade, then why we should do it above 200? We should save our fuel. So fuel will be wasted. That is first point. Second, we are using glass apparatus, and beyond 200 degrees centigrade, glass may not withstand. So there are tend to crack it. So they may tend to crack it. So that's why we are not using a high temperature. We will always go for temperature which is less than 200 degrees centigrade. Then Na2SO4. If this byproduct we will get, that is sodium sulfate, then what will happen? It leaves hard crust. Hard crust means whenever we know that in apparatus we have taken round bottom flask, and in that when sodium sulfate will be lying down, after reaction when we will check, we can see the hard crust of sodium sulfate, and it is very difficult to remove that hard salt crust. So it will stick to glass, and when we are taking it out, there are chances that we may break round bottom flask. So it is difficult to clean it afterwards. So that's why we are not using this reaction in which the sodium sulfate will form. So we are using this reaction in which sodium bisulfate will form, which will not leave any kind of hard scale in the round bottom flask. So what are the reasons why we are not using more than 200 degrees centigrade temperature? That fuel will be wasted. Second, we are using glass apparatus, so it may not withstand with that high temperature. And the third one, that sodium sulfate will leave a hard crust and it will stick to glass. So it is difficult to remove them when we are cleaning it. Two more reasons. Purification. Which step we are following for a purification? That we are dipping a gas pipe into concentrated H2SO4 and we are allowing hydrogen chloride gas to pass from concentrated H2SO4. And concentrated H2SO4 will act as a drying agent and it will remove all the moisture from hydrogen chloride gas. So, why we are using that agent? Because it will not react with hydrogen chloride gas. Suppose if it will react with hydrogen chloride gas, then we will not get a moisture free hydrogen chloride gas, but it will not react with hydrogen chloride gas, so it is safe to pass our gas from it and it will dehydrate it. So whatever moisture will be there in HCl will be taken up by concentrated H2SO4. And there are two other, calcium oxide and phosphorus pentoxide are also there for a drying agent, but we are not using them. Calcium oxide and phosphorus pentoxide. What are the molecular formula? CaO P2O5. We are not using them because they are reacting with HCl. If calcium oxide will react with HCl, it will form calcium chloride and water. Phosphorus pentoxide will react with HCl. It will make phosphorus oxychloride and metaphosphoric acid. So these two will react with HCl and generate a different product which are other than hydrogen chloride gas. So it is not as advisable to use calcium oxide and phosphorus pentoxide. You will get a reason in the exam that why can't we use calcium oxide and phosphorus pentoxide for a drying agent in hydrogen chloride gas preparation, and why? So when you are writing a reason, it is very important that you should address a chemical equation also. It is not just sufficient to write only a product name or just write that they will make some other product or other than hydrogen chloride gas. You do have to write this reaction and you have to show that which way it will react, and that's why we are not using it. Collection. What is a collection step? We are collecting in a gas jar, that is a gas jar which is filled with air and not with the water. So what is the reason behind that? When we are collecting in a gas jar, it will lift the air and the HCl gas will be down over there. Suppose this is our gas jar, then HCl gas will be down here and up it will be air. So in air filled jar we are collecting it. So why this will happen? Upward displacement of air. We are collecting it through the upward displacement of air. That means when the HCl gas will come in, it will lie under the air and not up of the air. Why? Because it is 1.28 times heavier than air. Hydrogen chloride gas is heavier than air. So definitely it will be lying down at the gas jar. And we are not collecting it over a water. Only a air filled jar we are using. Why? Because it is soluble in the water. If we are collecting in a water, then it may happen that some of our product will be dissolved in the water and we will not get a full product. So And also, what is the ratio of dissolution of HCl? That 1 volume of H2O will dissolve 452 volume of hydrogen chloride gas. So, whatever product we will get, some of the part of the product will get dissolved in the water. So, it is not advisable to collect over a water. We always collect a hydrogen chloride gas in a air-filled jar, and it will be lying down because it is heavier than air.